In this video, I will be explaining the principle of mathematical induction and how it is commonly used in most card tricks. Mathematical induction is a process that is widely used in mathematical proofs. It is most commonly used when you are trying to prove an infinite set using natural numbers. There are three main steps to proving a statement using mathematical induction. You must first prove that the base case is true. The base case is usually given by the initial statement using a constraint. You then assume that the statement holds for the kth term in the sequence. And finally, you must prove that the statement holds true for the k plus 1th term in the sequence. As an example, I'll be performing the trick divination by counting. To perform this trick, you need a deck of 52 cards in any order. You can start off by having a volunteer or yourself shuffle the deck of cards as thoroughly as you like. After that, you then take the deck of cards and begin dealing them down face up, counting up to 13 from the first card. Meaning that if the first card in the pile is a 9, then you deal down 4 cards on top of it to reach 13. You continue to make piles like this until you either run out of cards or you do not have enough cards to make another pile. Next, you have a volunteer flip 3 piles over at random without you looking. After they have flipped 3 piles, you collect the remaining face-up cards and discard 10 of them. You then flip the top card from 2 of the face-down piles and deal down a number of cards equal to the value of the cards you just flipped. After you have done that, the number of cards remaining in your hand should equal the value of the top card of the last pile. So to perform this trick, we start off by shuffling the deck of cards. As many times as you like. Order does not matter for this trick. So you can see that they are in a random order. I then start dealing face down. So I start off with 2, then I go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Next card is a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 10, 11, 12, 13. 6, 7, 8, 9, 10, 11, 12, 13. King is a 13. 7, 8, 9, 10, 11, 12. Okay, so I didn't have enough to finish that one, so we're going to set that off to the side. So then you have a volunteer, or in this case myself, pick stack 3 piles at random. So I'm going to do this one, and this one. Then these 3, I can take and place over here. From there, again, doesn't matter which pile you pick. So we're going to start off by just discarding 10 cards. 4, 5, 6, 7, 8, 9, 10. Now we flip one of the cards, so that flipped a 6, so we're going to discard 6 cards. 1, 2, 3, 4, 5, 6. From there, we're going to flip another one. Doesn't matter which one. So let's flip this one. So we flipped over a 3. We discard 1, 2, 3. Now, the number of cards remaining in our hand should be the number of the value of this card. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cards left in our hand, then this card, the remaining one, should be a 10. The basis of this trick lies in the number of cards in each pile. Every pile contains 14 minus n cards, with n being the value of the top card in that pile. After we collect all the cards and determine which pile will be our unknown, we get the formula 14 minus n plus 38 plus n equals 52, with 14 minus n being the number of cards in the unknown pile, and 38 plus n being the rest of the cards. From thereafter, we discard a total of 38 cards. We are left with n cards in our hand, with n being the value of the top card in the remaining pile. As proof for this explanation, we start off with the equation that we got from the previous slide and prove the base case as n equals 1. So 14 minus 1 would give you 13 plus 38 plus 1, which would give you a total of 52. Since the base case was true, we assume that it is true for the kth term. So we get 14 minus k plus 38 plus k equals 52. Now we need to prove it for n equals k plus 1. So we start off by plugging in k plus 1 into our initial equation, and then using our mathematical properties, in this case the distributive property, we then continue to work our way towards making it into our initial assumption of 14 minus k plus 38 plus k equals 52.